Hi, I am Xiaolan from Institute of Software, Chinese Academy of Science. I am very excited today to talk about our work on ChallengeDetect, investigating the potential of detecting in-game challenge experience from physiological measures. Introduction. Challenge is the core element of digital games. When playing digital games, players often have to use their abilities to overcome different types of challenge to make progress. Physical challenge depends on skills such as speed, accuracy, endurance, and strength. Cognitive challenge requires abilities such as memory, observation, reasoning, planning, and problem solving. Emotional challenge is a relatively new type of challenge. It deals with tension within the narrative or difficult material of the game, and can only be overcome with a cognitive and effective effort. Players encountering emotional challenge would be put in a reflective state of mind, and have more diverse and eudaimonic experiences. Perceived challenge is a complex player experience that arises from one's interaction with a game's intrinsic challenges. It typically manifests itself in four types: cognitive, emotional, physical, and decision-making. The complex challenge experience can be assessed using CORGIS, a valid questionnaire tool developed by Alena Denisova in 2020. However, when playing a long game scenario with rich contents and designs, the challenge experience may also exist jointly with one another, and can change dynamically with time. We want to investigate the possibility of measuring challenge experience comprehensively and dynamically using physiological measures. This would help to understand how different challenges are perceived by players throughout the gameplay, and further design games to adapt to players' different skills. Current work. Our work include two main parts. First, we conducted an experiment to collect physiological signals when interacting with different game scenarios. We also collected the challenge experience continuously throughout the game. We then used machine learning methods to explore multiple aspects of challenge detection. Experiment. We first constructed 3 game scenarios by choosing different game quests from Fallout 4. Each game scenario was sought after to cover all types of game challenges. We recruited 41 participants and each of them play only one of the game scenarios. For each game scenario, a series of game events were segmented to locate important data in the next step. Each participant received a series of experimental steps. The main part of game playing takes about 50 minutes. The challenge experience was rated continuously in every 30 seconds with CORGIS questionnaire. Each participant takes about 4 hours to complete the rating. Here are the experimental setting. Example of physiological signals. Some of the gameplay screen recordings. The software developed for challenge experience rating post-study. As different participants play game scenario at different paces, we also mark the start and end time of each game event for each participant. This figure shows challenge experience ratings of different game events. They are changing dynamically with time, coexisting with one another and showing significant differences between individuals. For each participant, we got their physiological signals, their experience of the whole game scenario, their ratings of different challenge experiences, and the mark time stamp of each game event. Finally, the physiological signals, challenge ratings, and time stamp data of 32 participants were collected to offer a novel dataset for challenge detection. This dataset is now released at GitHub for public use. Challenge detection. We used standard methods to extract signal features and determined labeled data samples. 7 widely used machine learning methods were adopted to train challenge prediction models, such as decision tree, random forest, neural network, and so on. We used 2 kinds of metrics to evaluate how accurate the models predict challenge experience. RMSE and MAE were used to evaluate the prediction of challenge rating score. 5 two-class classifications were used to determine whether a specific type of challenge experience has been activated. We employed 2 different methods for evaluation. In 10-folds validation, the whole dataset were equally and randomly split into 10 subsets. We found that RMSE error of challenge rating prediction reaches 0.74 to 1.09. Challenge activation detection accuracy reaches 83.1% to 87.2%. Random forest produces good performance near to DNN4. With Leave One Out method, data of each participant was treated as an evaluation set once, data of the other 31 participants were used for training. With different participants, RMSE error varies from 0.37 to 1.12. The detection accuracy varies from 55.6% to 99.8%. Here are some challenge detection examples with 10-fold method. Detection examples with Leave One Out method. At last, we used two feature importance techniques to identify 24 important features which could significantly reflect challenge experience. We also select the top 10 important features for each challenge type. As the figure shows. Contributions. In our work, we contribute a pipeline to detect challenge experience with physiological signals. First, we develop a novel dataset for challenge detection. Second, we explore the potential of detecting challenge experience with physiological measures. Third, we offer a set of challenge-related physiological features. We hope the pipeline would inspire game researchers, designers, and developers to view challenge as an important player experience. With this pipeline, it is possible to explore perceived challenge more thoroughly in future studies, thus to understand how players perceive different game challenges and to develop more meaningful and reflective biofeedback game interactions. That is our work of ChallengeDetect. More details can be found in the paper and the website released. Thank you very much for listening.